In this video, we will solve a problem involving a linear equation to predict a final exam score, and then we will discuss the risks and limitations of predictions that were made outside the original data range. Now, in the first part of the problem, the linear regression model equation is y equals 45 plus 5.5x, where y is the student's final exam score and x is the number of hours a student studied. To predict the final exam score for a student who studied 8 hours, we simply insert x equals 8 into the equation. The predicted score for a student who studied 8 hours is 89. Let's move on to the second part of the problem. Here, we are given that the original study data ranged from 1 to 10 hours, and we are asked to discuss the risks and limitations of predicting the score for a student who studied 20 hours. This is an example of extrapolation, which means we are predicting a value that lies far outside the range of the original data. In statistics, if a prediction is made within the range of the original data, it is called interpolation. This is considered more reliable than extrapolation because the trend is unknown and dynamic, and uncertainty increases outside the original data range. However, despite being less reliable, extrapolation has certain applications, such as forecasting future trends, setting business goals, and in fields like climate science or medicine where it's used to model future outcomes. Now, coming back to our case, predicting the final score for a student who studied for 20 hours is not a good idea for the following reasons. First, a student cannot score more than 100%, which limits the potential score and shows that the linear relationship doesn't hold indefinitely. Second, a student who studied for 20 hours is likely to experience fatigue or be less productive, meaning the positive effects of studying might not continue at the same rate.